So here we're going to take a look at moving between the different forms of linear functions, whether it's a table, a graph, point-slope form, or slope-intercept form. And then we'll go ahead and get some practice with our average rate of change formula and see how that's coming into play here. So with this first one here, we're given just a table, and if we know this is a linear function, it means that how we're moving from our input to our outputs should be consistent. So like to get from -9 to -6, we're adding 3 each time, and that's true across this entire table. So this is set up so that our change in inputs is always +3. Now if we look at our change in output, so to go from 14 to 10, what we did is we took away 4. And if it's linear, that change should remain the same too. So how our outputs change relative to our inputs should remain the same across the whole table. So we're taking away 4 each time as we move across our outputs. So to fill in the rest of the table, I'd go 6 minus 4, 2 minus 4, -2 minus 4, -6 minus 4. And that would fill in the rest of my table based on the fact that this is linear. Then with all those values, we could graph this. Let's see, the first value we could graph is a -6, +10. So let's see, 3, 6, 10. And then what we could do is follow the slope of -4/3, or we could just keep plotting these points, -3, +6. And 0, 2. And then we could just follow that slope across the entire graph there to get all the points we need and then connect them with a straight line. And there's our graph of our linear equation. Okay, so now putting this into point-slope form, what we're going to need is our slope. And what we could do is we could grab that from this table or from the graph, but what we're seeing is change in outputs, we were taking away 4, over change in inputs, which is where we were adding 3 each time. So we have a slope of -4/3, which we also see in our graph. We could look at our change in output. So we went down 4, right 3. So we'd have a -4 over a +3. So either way, that gets us our slope. And then for point slope form, we just need the slope and then choose a coordinate. And it could be any of these coordinates, doesn't matter which one. Let's go with, I'm just going to use 3 and -2. But you can do this with any of the other coordinates. So what we'll have is we'll have our function f of x, and then we're going to take away, and then we choose an output value. So f of a, so that would be the -2 is my y-coordinate. And actually, let's go ahead, and since that would be a minus a -2, we'll go ahead and write that as a +2 equals, and then we'll have our slope of -4/3, and then we'll have x minus, and then our input value a, which was the x value of 3. Or actually, I should be using t here instead of x, because that's how our table's defined up above there. So there's our point slope form using the coordinate 3, -2 with the slope -4/3. Now the slope intercept form, again, we have that slope of -4/3, and then from the graph we could see that we have our y-intercept of +2. So with that, we could go ahead and write this as y equals -4/3, and sorry, not y equals. Let's use our function notation. So f of t equals -4/3 t plus 2. And we can leave it like that. Now, if we didn't have all of these pieces and we just had the point slope form, I do want us to see that we could solve for our function here, getting that into slope intercept form by distributing the -4/3. So we would have -4/3 t plus 4/3 times 3 would leave us with just a 4. Subtract 2 from both sides, and that would get us our -4/3 t plus 2. So we could get there from solving the point slope form as well. Okay, average rate of change. And actually these should be t's as well, since that's our input value. So for this we take f of 6 minus f of -3 over 6 minus a -3. So f of 6, that was a -6 up above. So we're grabbing the y-coordinate that goes with our input of 6. And then minus f of -3. So at -3, our output is a +6 over 6 plus 3. So we have a -12 over 9. And simplifying that, we'll see -4/3. And this average rate of change should match our slope, because no matter what two coordinates we pick on our graph, the rate of change between those two coordinates should always simplify down to a -4/3. That's just a property of a linear function, that the slope remains constant and average rate of change relates to slope. So that is good that that's matching up, because that's how it should behave. Okay, with this one we're given a graph. So what we could do is fill in the table. So let's see, at -3, I can't quite see what's going on there. So let's go ahead and fill in values that we do know. So how about the 0, -8? Let's see, at -1, it looks like we're at -10. At 1, we're at -6. So it looks like we're going up by increments of 2 here. And that makes sense, because if we look at this, it looks like for each separation of 1 unit, we're going up 2 over 1. So I'm seeing a slope of +2 here. So with that, we'd have then a -4 and -2. So to go in the other direction to fill in the rest of the table, we're going to take away 2 from each of those. So even though they're off the graph, we can fill in that table because they do exist out there. Okay, so what we're seeing from this is a slope of +2 because of our rate of change on the graph. So for equation in point slope form, again, I'm just going to choose a coordinate. Doesn't matter which one. How about 2, -4? So that means we would have f of t minus the output value, which is a -4, so that'll be a +4, equals 2, and then we'll have x minus, and then our x, or rather t coordinate, so our input was a +2. And there's our point slope form, and then for slope intercept form, we would take our slope, and then t plus b, which we have the coordinate 0, -8, so that's going to be a -8. So for average rate of change, we would take f of 3 minus f of -1 over 3 minus the -1. So f of 3 from our table up above was a -2 minus -1, which is a -10, over a 3 plus 1. So this is going to be 12. Ooh, what did I do? Nope, we're good. I was doing quick mental math and was thinking I was going to get the wrong answer because I know it should come out to 2. So this is a -2 plus 10, so that should be a +8 divided by 4. And there is our +2 matching our slope, which should happen with these linear functions. Okay, so there's all sorts of different formats that we can work with our linear functions.